Okay, this is the introduction for lab number 4. We'll be measuring the speed of sound in air and taking a look at how air temperature is going to affect the speed of sound. One thing I will note is you do want to turn the volume down because this thing will play a loud noise at you and it kind of startles you at first. You might want to use headphones if there's people around you or if you're in the library or something like that. And you're going to open up this simulation right here. It's going to look like this. So let's go ahead and click on the begin button, and warning, it will give you a sample explosion sound when you hit the begin button, so don't let it startle you. You will hear it just now. So turn your headset down accordingly, and what we're going to do is we're going to set off an explosion. That explosion is going to be right down here, so bang, and we're going to put ourselves right up here, and we're going to measure how long it takes for the explosion to reach us. So you can kind of see 0 kilometers, 1 kilometer, and this would be 1.1, 1.2, 1.3, 1.4, 1.47, let's just say. So I would say that my distance is 1.47 kilometers, and we do need to convert that to meters, so let's go ahead and do that. 1 kilometer is going to have 1,000 meters in it. And you're going to multiply these together. The kilometer is going to go away, and for my particular setup, I would have 1470 meters, and we're going to go ahead and write that guy in the table. But before we write that guy in the table, we are going to hit the start button, and we're going to measure how long it takes. As soon as you hear the explosion, then what we're going to do is we're going to hit the stop button. So I've hit the start button, and the explosion has not occurred yet. The explosion is not going to occur until I push down on the handle, and that's when the timer is going to start. Again, you want to hit the stop button as soon as you hear the explosion. So start. And there was a little bit of lag there. You do want to do a little bit better, but now I can go ahead and say that I've measured the time that it took, and you do want to convert milliseconds to seconds, so 4809 milliseconds. And what we're going to do is we're going to say that in 1 millisecond we're going to go to seconds, and we would say 0.001 seconds. You're going to multiply that together, and we're going to get 4.809 seconds, and you're going to put that guy into the table. So let's pop back to the table. Here we've gone ahead and we've recorded our total travel time, we've recorded our total distance. Just go ahead and do that 2 more times, and hopefully you should get a little bit better at that, and take the average of them. So you're going to add those together and divide by 3. And then we're just going to calculate what the speed of sound is. Pretty straightforward. We're going to take our distance and divide it by time, and write down our speed of sound right over here. Then we're going to essentially do the same exact thing again. You're going to fill this table out, but we're going to try a different placement, and probably not surprisingly, the further away that you move, the longer the time is going to take, and hopefully you should get a little bit better at measuring that time as well. Then we're going to go ahead and measure this, see how the temperature is going to affect this guy. So what you're going to do is you're going to click on the frozen tundra experiment, and you're going to just repeat the experiment 2 more times, so distance 1 and distance 2. Do it 3 times, total travel time, average speed of sound. Again, the speed is going to be equal to the distance divided by time, and see how the speed of sound changes. And then what we're going to do is we're going to come down a little bit further and say, well, the accepted speed of sound at 0 degrees Celsius is going to be 331.5 meters per second. And then for every degree Celsius above that, it's going to increase by about 0.6. And so go ahead and calculate what the temperature for the hot desert was, and calculate the temperature for the frozen tundra, and think about what's going on with the speed of sound. Why does it change? Why does it depend on temperature?